And hello, welcome YouTube to this video of again Salome and how we want to mesh things. We've previously sort of done the most basic way of meshing a cylinder in the last video. However, this is not quite good enough just yet, because what you kind of need to do is that you need to add patches, right? You need to add let's say if you have a cylinder, apply and close, you will need to do this thing called create groups, and then what you need to do is to create individual groups of each face. So this is the main shape, and for each of these shapes you need to select, you need to tell what is your, let's call the top the outlet. You need to do the outlet. You need to tell this Salome what's the outlet, what's the inlet. So for example, this is the outlet, this is the inlet. So I'm just going to remove 10, I'm going to remove 3. Okay, so 12 is the inlet, and then I need a wall as well. So let's select all again. So this one I'll remove, this one I'll remove, and apply and close. So we have an outlet, inlet, and a wall. Okay, so this, having this around is the prerequisite for us to start patching things, having individual patches sort of outlined for us, and when we do the meshing, we can actually just create a mesh, and we'll take this cylinder one to be our shape. Cylinder 1 to be our shape. We do the net gen 1D, 2D, 3D, apply close. This is how we normally do it manually. Then we will click the compute, and this is what we'll get. And under mesh 1, we will have all the groups of faces here. Okay, so this is important to have, that you have individual faces. Now, of course, if you want to dump it to the Python file, let's bring the Python console to the front. So we'll just do it under thin pipe flow snappyx mesh, intermediate plus, Salome. I'll just put in the video scripts. So it's meshing with patches. So this is where we want to head off next. Okay, this is where we want to head off next, and I kind of sort of did it in my worked examples already, but I'll do it live in front of you as well. Okay, so this is where we are headed in the next few videos. And before I continue, I actually want to see, yeah, I want to also update you on some convenient things I've done with the workspace object. Okay, so what am I talking about here? So I have this linkGitWorkDirectory.py, right? Okay, this is the linkGitWorkDirectory.py, and what is here to do is that if you go to video scripts and you have a live demo cylinder class.py, okay, you go all the way down here, you notice that the workspace module here is meant to help you import the test modules and of course the mesh builder modules, rather conveniently when you sort of reload things. Now, let's say I make it even more convenient for you, and I give you a function that returns the workspace object. Okay, so this is the update that I want to share with you. So if you go to linkGitWorkDirectory.py, okay, you will see this thing called get workspace object. Okay, what is get workspace object? Okay, so from import library, import reload, then you will import the live demo cylinder class, and then you will just return a workspace object right here. Okay, that's all. And then this is the workspace object for the stuff I'm doing in the videos. Okay, if you want to load the workspace object in the not the live demo cylinder class, I would say it's more of the let me put this here, spell reloading correctly. Okay, you just call it the cylinder class module under worked examples. under worked examples. So there are two different workspace objects depending on which class you are going for, the one that I'm demonstrating in front of you now, or this one. Okay, so, and even better, I actually tell you how do you how do you actually access these functions. So for example, if you want to load workspace, you have to type this from linkGitWorkDirectory import workspace object self equals get workspace object. So every time I have the self, that is the workspace object. Okay, so let me show you how it works. I'm going to close Salome and I'm going to open it up again. Okay, I'm going to quit this. 2, 3. Then I'm going to Salome and I'll run it in the background. So I run this, and here's the Python console. And as usual, the way we start is import linkGitWorkDirectory. Okay, then you'll see all of this, right? So you'll see these two bits of code here. It says to load workspace, type this, and then you have self this. Or if you want to get workspace from the work examples, you just type this. Okay, which basically means you can just copy and paste here, for example. So you just copy these 2 lines of code here and you load the workspace object instantly. Or you can, if you want to get the workspace object from the live demo one, you can do this, and then it will also load the workspace. So that's just the added bit of convenience I've updated into the linkGitWorkDirectory. Hopefully you will find it useful. Okay. So let's just get started on how to work with groups. And for starters, let's take a look at the okay, Salome. And let's go to, where are we? Yeah, we go to video scripts and we'll look at the mesh and export, meshing with patches. Yeah, meshing with patches.py. Okay, so this is the first place we can actually take a look at how to sort of get started. Okay, so we have a lot of geometric objects here, but yeah, it's a lot of things here because I've been doing a lot in this Salome. Okay, but where I want you to sort of zoom in will be, okay, maybe let me start from scratch. I will reload this script. Okay, so we'll quickly get the thing started. We'll have a cylinder. Okay, we have a cylinder, and you can actually instead of just choosing a cylinder with radius and height, you can actually set the base point and vector. What am I talking about? If you want your cylinder center to be elsewhere, you can use this mode on the left over here. So I'm going to quickly use that to construct a cylinder. So it needs a base point and a vector, right? So that I need to make a point first. So I will have a point at -150, 0, 0. That's what we call vertex 1. Vertex 2 will be at +150 because the cylinder is 150 so-called meters long, 150 mm long or whatever. Okay, I'm going to create a vector and I will use these 2 points, vertex 1. Okay, let me try again. This one is 0.2, 0.1, and 0.2. So I'll make a vector here. You can see the vector is pointing upwards in the z direction. Now I can use these vectors to actually make the cylinder. So I'll use the base point. This point is at like the bottom of your cylinder. So I will say, yeah, I want vertex 1 to be my base point. I want this vector to be my vector to point where the cylinder should grow. Okay, so I'll just apply and close, and here I can have a cylinder that's slightly, is different. It has a different center than before. Okay, once I have this cylinder, maybe I'll call this cylinder 2. Cylinder 2, because we made this cylinder a little bit differently from what we normally was doing. So again, we'll just create group I'll just quickly call it group 1, group 2, and group 3. Or rather, let me remove this. I'll just select it graphically. Right? So this is, let me add this. We'll call this the outlet. Let me add this. We'll call this the wall. And then we'll call this the inlet at the bottom. Apply and close. So we'll have an outlet, wall, inlet, outlet, and wall. Once you're ready, we'll quickly go and mesh it. And again, let's do the meshing. We'll do create a mesh. Oh, create mesh. We'll have this geometry. We'll call this a cylinder 2 mesh. Geometry will be this cylinder 2. Okay, and then we'll have NetGen 1D, 2D, 3D, apply and close, and we'll just compute this thing. Okay, then be done very fast, and the groups of faces will be here: outlet, wall, and inlet. Very good. Things are good. Things look nice. Let me just export this to the Salome directory. Pardon the time wasted, but let's go to video scripts and let's do meshing with patches.py. And there we go. Okay, let's vim meshing with patches to see what it looks like. Meshing with patches.py. So, okay. Now the code's a lot shorter, we can actually make sense of what's going on. So here's all the import stuff. So we actually did that before. Here's the origin. Here's where we make the origin. Here's where we make the 2 vertices for the second way of making cylinder. So you see this is a geom.py mixed cylinder. We supply a vertex 1, we supply a vector, we supply radius, we supply a height. Okay, so this vector 1 was made using geom.py.makeVector. It starts from vertex 1, which is the initial point, and it goes to vertex 2, which is the final point. So make sure the syntax of all your vectors starts from the initial point and goes to the final point. So this part is where we start to make this how do you say, make this outlet and inlet. So for example, here's the outlet. Okay, so here's the outlet, and it selects this face number 10. How did they get the number? We actually had to go and take a look at the user interface to get this number 10. Okay, so that we know 10 actually refers to the outlet. Now that makes a problem for us in terms of coding, because how do we know which face number represents which face, and which what do you call that? Yeah, which face number will represent which patch or which face. So that's a very tricky thing. There's a way to do it, but yeah, let's just finish the code before we get to that. Here's the one where we add the wall. Again, you see this thing called create group, cylinder 2, blah blah blah, shape type face. Inlet will be here, geom.py create group cylinder 2, blah blah blah, again create face. And then outlet, wall, inlet equals geom.py get existing sub-objects cylinder 2, blah blah blah. Okay, so and after all of this is created, you start adding things to study. So this is the one where we have the origin x, y, and z. This one is where we add our vertices, vectors, and cylinder. And then you see this little new bit of code here that says add to study in father. So what's add to study in father? Well, normally when you add to study, you see that over here, this geometry module, it will be sort of on this main level, right? It's under the geometry module, it goes one level down. Okay, and under the cylinder 2, for example, under cylinder 2, you'll see there's an outlet, wall, and inlet that are like parts of this cylinder 2. You can collapse and expand. So if you want to add these patches to this cylinder 2, then you'll need to, I guess, use this thing called add study to father. Okay, so that's important for defining your OpenFOAM patches. Okay, so after that, yeah, that's basically it for your geometry. Then after that, you need to have your net gen 1D, 2D, 3D. And then over here, this is the extra bit of thing you need to do for each of these patches. So for example, cylinder 2 mesh group on geom, outlet, then outlet is this object which you defined here earlier. Outlet is this object over here. Okay. So you define it using these 2 lines of code. That will be your outlet. Then you have to attach it to this smesh face, whatever this thing is, right? So smesh.face, yeah, you have to specify that it's I guess it's a face. Same thing for your wall and inlet, right? So that's your wall and inlet. And then you compute it. And I guess here is where you start getting your groups in order of the way you define them. So if you actually define outlet 1 first, then I guess this is your first argument. You define wall 1 next, then this is your next argument. You define inlet 1 lastly, then you'll get your inlet 1 over here. So cylinder mesh 2.get groups. Why is this important? It's because that after that you'll need to do this thing called setting of the name on your mesh objects. So outlet 1 will be aptly named outlet, wall 1 will be named wall, smesh set name will be, inlet 1 will be named inlet, and then you'll get the mesh called cylinder 2 mesh. Okay, so this is everything, then you kind of update. So this is how the code goes. With the addition of faces and patches, things may get a little bit more complicated, but don't worry, I'll walk you through them. Okay, let's save and quit. So from a conceptual level, yeah, everything is pretty straightforward, except, how are we going to, for example, if you take a look here, how do we know which face represents which patch? So how do we know phase 10 will mean outlet? How do we know phase 3 will mean the wall? How do we know phase 12 will represent this inlet? Okay, so that's the confusing thing. And so after some length of thinking, debugging, well, there's a interesting tool that you can use. If you look at this thing called you have this thing called point coordinates under inspection, basic property, center of mass, inertia, normal to a face. So some ways you can actually differentiate the different patches. Okay, so for example, if you want to differentiate the outlet from the wall from the inlet, how do you do so? Okay, one of the ways is to use a normal vector. Use a normal to a face, and the face is this outlet, for example. So I'll apply this. Then I want the face to be the wall, and then the inlet. You can see that the normal vectors are different. So if you know what these normal vectors are, and you sort of do an if loop to say that if the vector's pointing upwards, it's the outlet. If it's pointing downwards, it's the inlet. If it's pointing sideways, then it's the wall face, right? It's the wall face. Because if you take a look at this wall, you'll see that this vector actually points out at this cut thing over here, and the other side is smooth, right? So, oh, this is the x-axis. All right. So the normal vector is this one that's pointing outwards here, away from the cut. Is actually on the smooth side. So it's at the center of the smooth side. So first over here, that you can see this line coming down here. All right. Okay, so it's pointing in the negative x direction. Okay, so one way of doing it is that if you have these vectors pointing in the certain direction, you can sort of differentiate these faces. That's one way of doing it. However, there is an easier way, which I found out. I actually tried the vector way. It was kind of complicated and time consuming. I'll just show you the easier way. Okay, one thing you can do is this thing called minimum distance. You take a look at this thing called minimum distance here. It will allow you to take the minimum distance between two objects. So the object could be a face and it could be a point. So for example, let's say I just want to take a look at the inlet point, right? I'll take a look at the inlet point. Well, if I say I want to compare this I want to take the minimum distance between vertex 1 and this inlet, the answer should be 0, right? Because yeah, that's where the bottom of the cylinder is. The point and this disk, they are exactly at the same place. So the minimum distance will be 0. So let's try that. Try the minimum distance between the inlet and vertex 1. So you can see that the length is 0, dx, dy, dz is all 0. Okay, that is one way. Well, we can actually use this to test whether this plate, what do you call that? We can use it to test whether this face or this patch is the inlet. Okay, now consider this. If you want to sort of say compare vertex 1 to the wall, okay, what is the minimum distance between vertex 1 and the wall? Okay, I want to let me try again. I want to unclick the inlet. Let's take a look at the wall. So this is easier. Since you see this vertex over here and the wall. So let's go to this thing. Let's go to minimum distance again. Look at the wall. And then the other thing we want to compare is vertex 1. So what is the solution? The length is actually 100 units or 100 mm or whatever. Okay, 100 units over here. Okay, so what is this 100 units? This 100 units is actually the radius of your cylinder. So you can see that if let's say you have a vertex 1 or vertex 2, if your vertex 2 is this top, yeah, okay, never mind. Let's just, yeah, what's vertex 2? Yes, vertex 2 is the point that corresponds to the top of the cylinder, right? So if you have a point that corresponds to the top of the cylinder, and then you also get the minimum distance, it will also be the radius. So if you have I guess one of these points along the z-axis, and if the cylinder is centered on the z-axis, then definitely the minimum distance will be your radius. So that's a nice thing about having these vertices. You can use this to compare whether this is the wall patch or wall face. And so if this is the wall face, the minimum distance between this vertex 1 and the wall will be, of course, the radius. So that's what we saw just now. It was 100 units. Okay, so we can use this to our advantage. And last but not least, we can also take a look at the last piece. The last piece will be the outlet. Okay, the outlet's here. And then we can compare the distance between the outlet and vertex 2. Again, the minimum distance should be 0. Okay, so we'll have the outlet, and you see the minimum distance is 0. Okay, so how then do we use minimum distance here? So Salome, Python, and minimum distance. Okay, so this will provide the minimum distance between two geometrical objects. So this is the syntax that you see here. Okay, this is the text UI or the terminal UI commands. So this is the minimum distance. You use geompy minimum distance, shape 1, shape 2, or object 1 and object 2. That's all you need to do. So I will be using this minimum distance to actually sort of differentiate between each of the patches. At least that's on the conceptual level. Okay, the getting to the coding and the nitty-gritty is a little bit more messy, but it is definitely doable. I just did it in the work examples. And okay, let me delete, and we'll delete the mesh module as well. I'll show you the worked examples and I'll call it a day. Let's go back to the geometry. So let's do this one from git linkGitWorkDirectory, import get work examples object, and then let's get this worked examples workspace object, and let me show you before I call this a day. the worked examples, I will go to cylinder class. I'll show you what this test is like. So this is the face naming test. So I actually built a cylinder, I get the cylinder object first, and then I call this code called build cylinder 2. Why is it called build cylinder 2? Well, it's basically building the cylinder using that vertex and vector. So once I'm done with that, I start playing with the face objects on in the group. Okay, so this one is something I've not introduced yet, but that's very important. I will do it in upcoming videos. But basically, once I make this cylinder, I can actually extract a list of faces from this cylinder. I can get their ID, and actually in this codes over here, I use the minimum distance to differentiate between the faces. So for example, if you go up here, okay, you go up here, I have this add inlet to cylinder. So I have a cylinder 2, for example. Okay, and then I have this inlet point. Okay, inlet point is this object. Okay, I just now showed you the vertex one at the bottom. And then I have the face, which I want to compare with. It could be the inlet face, it could be the outlet face, whatever. But the criteria I use to differentiate between the faces is that the minimum distance must be 0. And if the minimum distance is 0, then I can start doing whatever code to add this inlet face into Salome. Okay, same thing for the outlet. The basic idea is to get the minimum distance between the outlet point and whatever face. And if the minimum distance is 0, that face is the outlet face. So this is what this code is doing over here. Same thing for the wall. The wall is over here. I get the wall face. And then I use this inlet point as a reference point. And then I get the minimum distance, which should be the radius. So the difference over here is the minimum distance and the cylinder radius. And if this difference is 0, then I will say, yes, this is the wall face. Okay, so that is roughly what the code is doing. And let me just show you how it's done. So let me let's get test equals self get test object. And from this test object, I want to run this thing called face naming test. So this is the automated face naming test. Face naming test. Okay, so when I just add this, it will make this cylinder. This cylinder will have the following patches: the inlet, wall, and outlet, all automatically done. So that's the beauty of this code. I have not quite done the mesh part yet, but this code will be updated sooner or later. So that's all I have for you. Maybe in the next videos, I'll show you how to construct the code, demonstrate it for you. Okay? Yeah, see you.